This video is to go through the first two derivatives for carboxylic acids, esters and amides. Now I've already kind of covered some of this stuff in the notes to create esters and amides in terms of how to name them and things like that. But otherwise I'm going to go over other practical things you need to know. I am glossing over some details that were in the original notes that you can see still if you go back to the original post from this chapter when I gave you the notes. But I'm just going to talk about the things that you definitely need to know for a quiz or a test. So when I look at an ester, I know that this is an ester because I can see the oxygen. It's kind of like looking at a hemiacetal that has a double bond to oxygen instead of a hydroxyl group. So I can see all these different parts, and I still need to identify the same kinds of things. Like in a hemiacetal, I would need to know that that was the carbonyl carbon, right? So the carbon that's connected to two oxygens is definitely the carbonyl carbon. This part of my ester came from a carboxylic acid, whereas this branch that's hanging off on this side came from an alcohol that formed this ester. So again, it's actually very, very similar to looking at a hemiacetal, right? But instead of having an aldehyde that it came from and an alcohol, it's a carboxylic acid and an alcohol. So I need to be able to identify those parts so I can name this ester. That's one of the main things we're going over here. So to name this, I actually need to know the name of this carboxylate anion. I need to know that this was a 1, 2, 3 propanoic acid. I need to know that I changed that ending. I'm not actually going to call this propanoic acid because there's no hydrogen here, right? So just like when we were talking about carboxylate anions, I drop this ic acid, I add an ATE to the end. So now it's a propanoate. And that's the main portion of this name. It's a propanoate. And then I just attach my branch over here to this, right? So that's called an isopropyl. So this is called an isopropyl propanoate. Pretty simple. Figure out what part came from your carboxylic acid, name that first, right? Have the idea in your head, right? I typically would go straight to propanoate. I wouldn't call it a propanoic acid first, but maybe you have to go through those steps to identify and figure out how to name that thing. But otherwise, the other branch over here came from an alcohol. It came from an isopropyl alcohol, so I use that isopropyl as my substituent name here, right? That's branched off of my propanoate. Otherwise, the other things you have to be able to do with esters besides naming them is if I gave you an ester, you should be able to break it down just like you formed it, right? So if I had some water available, because I need that to break this down, and I had the right conditions, again, it's supposed to have that acid catalyst from before, forming and breaking down esters, it's a reversible reaction. But I'm going to bring in this water to break this apart. And again, all I'm doing is taking this thing and dividing it into two pieces. That came from my carboxylic acid. The other part, that's just 3 carbons right now, came from an alcohol. And I need to understand that that water was used to give me that hydrogen back and to add a hydroxyl group to that isopropyl on the other side. So now I have my propanoic acid and my isopropyl alcohol that were used to make that ester. So you can break down an ester just as easily as you can form one, right? It's a reversible reaction technically. So it's really the same thing we did in the last set of notes. It's just going the other direction. That arrow should be pointing in both directions. That is a reversible reaction. You can form and break down an ester in the same conditions, in those acidic conditions. So again, just want to be able to name it and break it down. So if this is my ester here, I want to be able to name it, I want to be able to break it down. So again, I flipped it a little bit. You're supposed to think about, okay, what would be my carbonyl carbon? Well, carbon is connected to 2 oxygens because that carbon is part of your carboxylic acid. So this portion of my ester here comes from my carboxylic acid. Now with 1, 2 carbons, that would be an acetic acid. I usually say acetic acid. You could also call it an ethanoic acid. But I want to change the ending, so I'm not going to call it acetic acid. I'm going to call it acetate. Right? ATE ending because there is no hydrogen there. This is part of that ester. Right? So use your carboxylate name. Again, this could also be an ethanoate. I just don't usually use that name for 2 carbons, so that's not what I went with initially. You can use either one, whichever one you want. But then I also have this branch that's attached to it. And remember that benzene ring as a branch is called a phenyl with a YL. So this thing is called a phenyl acetate. Simple as that, right? Name your carboxylate first, then put the branch in front. Whatever else is there is your branch, put that in front. I can break down this I can break down this ester again. If I give you a prompt like this, remember you can always assume that there's water. So I just add in a water if it wasn't given to me to begin with. But when I break this down, I'm going to do the same thing I did last time. I have both parts that I've essentially divided. Maybe I can draw it like this because that's the way it looked originally, right? So I break this bond right here and I separate those pieces. And then I realized that, okay, I'm going to add a hydroxyl group to this thing because it was my alcohol to begin with. I also need to put a hydrogen on this carboxylic acid over here. That oxygen and 2 hydrogens, that came from my water that I used to break this down. So again, I'll have 2 products here, 1 alcohol, 1 carboxylic acid. You just got to identify which side's which. And you should still be able to name those products. This is a phenyl. Remember, OL is different than YL. They sound the same, or they sound similar, but they are different. And this thing is an acetic acid. I'm not saying acetate because now I do have the hydrogen here, right? Now that could then lose the hydrogen and become a carboxylate ion again, but right now, the way it's drawn, it's an acetic acid. So name your ester, break it down.